Welcome to another edition of the Chemistry Corner. It's been a while. In our last episode, our chemistry hero was trapped in a cave by two polar bears. He was only able to escape by throwing water on them and thereby dissolving the polar bears, because we all know polar dissolves polar. But today, it's all about the base. We are going to look at how when you get more moles of base than acid, strong base, when reacted with weak acid, the pH is determined only by the concentration of the strong base, the sodium hydroxide. So let's introduce you to the class. Okay, so when we were discussing weak acids, we were specifically looking at acetic acid plus sodium hydroxide. When we react those two together, you know that we will produce sodium acetate plus water. Now, the water isn't really important in this problem. We've learned how to do it when you just have weak acid. And when you have just weak acid, you're at that point on your graph. When you have more moles of weak acid than strong base, you're in that portion of your graph. And when you're at the equivalence point, there's another way you solve for the problem. So we've gone over how to solve when you're here, when you're in that region, and when you're at point number 3, the equivalence point. Today we're going to learn what do you do when you're in that top region, region 4, when you have more moles of base than you do of weak acid. So let's continue. So this is when we've got more moles of base. So we had, I believe, 50 milliliters of a 0.100 molar solution of acetic acid. So we're going to do a before-after table. The before, we take our milliliters, convert it to liters. So we have 0.05 liters, and in 1 liter there's 0.100 moles of our acetic acid. So when we calculate that out, it comes out to be 0.00500 moles of acetic, which I'm going to abbreviate as HA. Now what do we do when we have more moles of base? So suppose in this situation we've got, let's make it 20 milliliters of a 0.400 molar solution. Now, the volume of acid is more, but that doesn't matter. What we care about is the number of moles. So just as we did here with the acetic acid, we're going to calculate the moles of sodium hydroxide. So 0.020 liters. 1 liter is 0.400 moles. And that's going to give us 0.0800 moles of sodium hydroxide. So as you can see, there are more moles of base than there are moles of acid. 0.0800 versus actually I believe there's 2 zeros here. There you go. Okay. So when you got acid and base, they will react with each other to neutralize. So after the reaction, there will be no acetic acid. It will all have reacted with the sodium hydroxide. We will, however, have leftover sodium hydroxide. We will have that many moles of sodium hydroxide left over. Okay? In addition, we will have created some sodium sulfate. Because this is the limiting reactant, after the reaction, we will have created 0.0500 moles of sodium acetate. Now, this is a weak base. This salt, I should say, this salt will create a weak base. The anion from the salt will react with water to produce acetic acid and OH minus. Okay? So the anion from the salt will react with water to produce OH minus. However, the amount of OH being produced from this reaction is insignificant because you have leftover sodium hydroxide. Sodium hydroxide is a strong base and will break apart completely, whereas the acetate is the conjugate base and it is a weak base, and therefore it will not generate very much OH minus. So when it comes to calculating your pH, all you care about is how much leftover sodium hydroxide you have. Since I have after the reaction, .500 molar, not molar, I'm sorry. After the reaction, we have 0.0300 moles of our sodium hydroxide. And if you recall, we had 50 milliliters of the acetic and 20 mils of the sodium hydroxide. So after the reaction, our new volume is going to be 0.70 liters. And so when we calculate the molarity of sodium hydroxide after, actually that's 0.03. Our molarity is 0.04 with 2 sig figs, 0.43 molar of sodium hydroxide after the reaction. So now we can use the concentration of OH from the sodium hydroxide to calculate the POH. POH is equal to the negative log concentration of OH. So the POH is going to be equal to the negative log 0.043 molar. And so our POH will be 1.37. And then the pH plus the POH is equal to 14. So our pH is going to be 12.6. Okay? So these problems are difficult because you need to know what region of the curve you're on when you're dealing with a weak acid and a strong base. Because like I said, if you just have acid, you're at that point on your pH scale. On the x-axis, you've got volume of strong base added. So when you haven't added any base, you are at that point and you do an ICE table for figuring out the pH. When you're in this part of the curve, you have more acid than base. And so then there's a different way of solving the problem, which we've already gone over in class. When you hit the equivalence point, you have equal number of moles of acid and base. And what we just did now is, what do you do when you're in that top curve in section 4? All you have to do is figure out how much of the strong base you have left over and plug that into the POH to find out what your pH will be. Well, hope you've learned a lot. And until next time, this is Mr. Strauss in the Chemistry Corner, signing out.
Don't add on to it. Okay. I just had 1, 2, 3. Watch this. Watch this.
I'm watching.
I got another owie today. No, I got 3 owies in one day. Watch this. That's really loud, Dada.
That's really loud.
One of the